So now we're going to take those algebra properties that you're already familiar with and some of the geometry properties, and we're going to put them together and kind of begin the process of understanding what it means to prove something. Okay, and we're going to start with something that you've done for a long time, so you already know how to do this. You're just now going to give the reason for each of your steps. And that is that we're going to take an equation and we're going to solve the equation, but as we solve, we're going to name each justification, each property that we used to solve it. Okay, so I wanted to kind of first go over, I have this blacked out because we're going to fill this in just a minute, but in general, here's what you're going to be doing. These are some guidelines for justifying and proving. So the first thing is you have to include every step. A lot of people, when you've done this for enough years, you kind of take some shortcuts when you're doing your solving of equations. When you're justifying your steps and proving your steps, you have to write out each step. Okay. Another guideline, you always begin with the reason for how you want to set up the equation, okay? So I'm going to be given a figure like this, for example, okay? And I'm going to be told some given information. That's always a given. So the diagram is given and then something else is given. So for example, here it says XY or segment XY equals 42. Okay, you can probably tell because this is something we've already done, but this is a segment addition postulate, okay? The value of this and the value of this would equal the total of segment XY. So what I just did was I basically set up an equation here. I said segment XZ, which is this, and segment ZY get added together to make the entire segment. Okay? Well, I'm going to begin with why I'm setting it up that way. What am I trying to do? Well, I'm trying to solve for n. But what I'm going to be doing when I set up my equation is I'm going to be using the addition or segment addition postulate. So my very first thing is my setup. What is it that I'm going to be doing when I get ready to solve this? Why am I going to add these two together and set it equal to 42? Well, because that is the idea behind the segment addition postulate. So you always begin with the reason for how you want to set up the equation. From there, you're going to be doing a bunch of algebra steps. And the guideline is that you're going to use properties, definitions, postulates, and theorems, which we've not talked about yet, but that have already been proven to justify each of your steps. Okay? And then the last guideline is you want to justify each step. Okay, that means that you're going to look at the step before it, and they're not going to show you every single thing they did. You're going to have to look at what was in the previous step and how they arrived or what was done to arrive at the new step. Okay, so let's look at a couple of examples here. Let's do this example on the next page, and you'll be able to see how we set these up. Okay, so we're going to be filling in the justification for how we're solving this problem. Okay, basically I'm trying to solve for n. Okay, that's what I'm going to arrive at the end. I'm going to be able to solve for n at the end. Okay, so I want to figure out how I arrive there. So the first thing that's given to me is that the entire length of this segment xy is 42. And then we already mentioned in the previous exam or the previous page that if I'm going to solve this for n, I'm going to use this and these values to do that. I'm going to eventually set them equal, set them up, okay? So why am I doing that? Well, because the only way that I could find the value of n in this example is for me to add up the two smaller segments to equal the total. So segment XZ plus segment ZY is going to equal the length of the entire segment. And that is the definition of the segment addition postulate. So you would write segment addition postulate. That's the reason that my equation is going to get set up the way that you see it set up here. Okay, so then the question is, what did I do from here to make it look like this? Well, you could probably tell that XZ is being replaced with 3 times n plus 4 because that's what it says XZ equals. And then you could probably see that ZY is being replaced with 3n because 3n is what it tells us ZY equals. And then obviously XY, which is what they told me about right here, is being replaced with 42. When you replace one thing for another in the equation, that is called the substitution property. Remember, we talked about the substitution property says that if A equals B, then B can replace, or A can replace B, or B can replace A in any expression. This is an expression. I'm just simply replacing it with other things. Each thing is being replaced by something else. Substitution property. Okay. All right. So let's look at what I did next. So this was my equation right here. This is the equation I'm going to solve. And I did something to this equation in order to arrive at this. Now this is really not a property, okay, that I did. This is more like a simplifying process, okay? So let's look to see what I did. I took this, well actually I'm sorry, this one I did do a property. What did I do to the left side? The left side's what looks different. What did I do to the left side to make it look like that? Well, you should be able to tell that the parentheses are gone. How are the parentheses gone? Well, that's because I distributed the 3 to the n and the 3 to the 4, and I got 3n plus 12. So that is called the distributive property. That's how I got from this step to this step. Okay? All right, so now let's look at the next step. How did I get to, or what did I do to get from here to here? You should be able to tell that it doesn't really relate to any property. I didn't substitute anything. I didn't add anything to both sides, so I don't have an equality property. What I did was I took this 3n and this 3n and I just simply combined like terms and added them together. Okay? That's not really a property, that's just called simplifying. And how did I simplify? I'm just going to put that I combined like terms. That's my justification. That's how I got 6n. I simplified by combining like terms. Now we're going to get into some equality properties, okay? How did I get from here to here? What's missing? What's different? Well, the left side no longer has a 12, and then the right side is no longer 42, it became 30. Well, what would I do in this equation to solve for n? Well, the first thing I would have done is I would have gotten rid of the 12. How did I get rid of the 12? Well, you could probably tell you subtracted it from both sides. So that's the subtraction property of equality, but you can just write subtraction property. If I subtracted the same thing from both sides of the equation, then that is how I got rid of the 12. And then the last step is I'm going to take this 6n equals 30 and solve it for n. How would I have done that? What did I do to go from this step to this step? Well, you probably could tell that you divided off a 6. That's how I got n equals 5. So that is the division property. I divided the same thing from both sides of the equation to get to the answer. So that's an example of how you do a justifying process by going through each step in solving the equation and justifying it with a property. We're going to do an example in a minute with the angle addition property.